Hey guys, this is Patrick from STH. It's not often that I get to show you something that could be a complete game changer for a wide variety of industries, but I think today's video is going to be one of those products. Specifically, we're going to take a look at this over here, which is the Xilinx KV260 Vision Development Kit, or Vision AI Starter Kit, and inside we have this little board right here. Now I know what you're thinking. One, you've seen development boards before. You may also be thinking, hey, Xilinx, that means FPGA, isn't that right? Answer to that is yes. And you may also be thinking, wait a sec, FPGA, that means terrible setup. And well, that's what we're going to be doing today. There are really two major innovations with this board. The first innovation is that there is the Kria K26 module, which is this part that's under this red heatsink fan, so this cooling unit that's right here. There's a carrier board which is holding that little board as well. So that SOM, or system on module, is really kind of the first step in terms of the innovation. But the innovation, I think, in this particular product goes way beyond that SOM. What Xilinx is basically doing is they're making it easy to actually use a FPGA. Now, a lot of folks have used CPUs and a lot of folks have used GPUs out there, but FPGAs maybe not, or at least maybe you didn't know that you were using one at the time. The traditional model to use an FPGA was pretty laborious, let's face it. You would basically go, you'd use some kind of custom tool, whether you're in the Xilinx or Altera or someone else's, but usually the Xilinx or Altera, now Intel ecosystems. And you basically, back in the day, had to program almost everything from scratch. And I don't mean like program like, oh, I boot into Linux and I just start doing my Python programming. Oh no, you actually had to go and route and place logic. You had to go define maybe your memory interfaces and all that kind of stuff. You'd have to basically do absolutely everything. And then not only would you have to do that, but you probably had to have someone go out there and design the PCB that this was going to go on as well. So as you can imagine, that's not necessarily something that is as easy as picking up something like a Raspberry Pi. I mean, if the barrier to entry is that you have to go and design your PCB and all the components that go on that, and then you have to go do all your logic for it, and then you kind of have to go build up what you actually want in terms of your application from there, that is a total pain. So while FPGAs have always been very flexible, they've also had a really high barrier to entry. And that's basically led to three types of people that do FPGAs. First, they're the people that are really into the tools, they know it, and this is what they do as a day job, and those people are absolutely awesome, and they are very comfortable in the FPGA environment. FPGAs are used in a ton of different applications. For example, you'll have something like a Microsoft Project Brainwave, where you actually have the network to a server come in through an FPGA. You can have logic for AI inferencing there. And so Microsoft is able to do basically their AI inferencing without having to ever hit the host CPU in those cases. But another really big domain is also just in terms of video AI and analytics. Because FPGAs are very flexible, it means that you can go deploy something like a facial recognition or a person tracking, something like that type of solution on top of FPGAs and do it relatively easily. So there are definitely people that are okay using it at some level, but not maybe necessarily all the way down to the hardware design. And okay, that's fine. But then the third group is really like everybody else. I mean, the vast majority of software developers, if you want to go develop for an accelerator, you don't want to go design the PCB around it. You don't want to go design, the memory interface because you don't need to. And so what's kind of exciting is that Xilinx has really kind of figured that out. Instead of just selling the chip, we now have SOMs like this. And to just kind of give you some sense of why this is important is really, I just kind of use this as, let's say, just for example, hypothetically here. Let's say that during COVID, you had a kitchen table, but you also were setting up a YouTube studio. So you decided to take your kitchen table, say, there's not gonna be people coming over anyway. And you decided to take that, cart it all the way over to your YouTube studio and, perhaps, use your kitchen table or what used to be your kitchen table as your YouTube studio table. I mean, I'm sure a lot of people have done that. Now, let's also say because of vaccinations, well, maybe a significant other is like, hey, you need to go get a table because we need a kitchen table again. You're basically faced with two options. One, you could go to somewhere like a Home Depot or Lowe's and go buy all the lumber and then go figure out how to go put it together and buy fasteners and a whole bunch of tools that you probably never use again, but you think you really need for that project and you get probably some of the wrong tools as well. Or the other option is you just go to a furniture store or you order something online, it shows up at your house and then you have a kitchen table. So faced with those two options of either the easy mode of just ordering it or the hard mode, the old version of getting an FPGA and using an FPGA was basically the Home Depot method.
That's crazy, Uncle Pat.
Hey, thank you, ladies. For anyone out there, that is both Grace and Emerson. They're my nieces, and they really wanted to be in one of Uncle Pat's videos, so they are making a cameo today instead of me telling you that you could get the STH merch down below. So thank you, ladies, for making this video way more exciting. And what we're gonna do today is going to be really kind of fun. So Xilinx says that this is very easy to set up, that this Kria, this new SOM thing is super easy to set up, says it takes less than an hour to get it all up and running. Previously, Xilinx had boards like the Pink that were supposed to be easy, but they really weren't. They were actually really not that easy to use, frankly. But now they're saying that this is way easier to use. In fact, it's so easy that there's even things like app stores, so you can just kind of download and go with the FPGA. So to test the 1 hour or less claim, we have exactly, as we're looking at this now, 58 minutes on this memory card. And we're gonna see if I can get this set up before this memory card is done. And I don't mean set up like I want this thing powered on. I mean, we wanna go and let's see if we can get an accelerated, video, like an AI vision type of algorithm running on this board in under an hour from this has no storage or anything on it. So let's see if we can go do that. Now Xilinx did send this board. They also sent this, which is a little 3D printed holder. And I'm gonna actually use this little 3D printed holder. You can get apparently the design file for this online, but I wanna use this just so you can actually see it, because otherwise you're gonna be looking like at a plane and that just will look not good on camera. All right. We snap it into place like this. We're gonna go put this over next to the monitor and we're gonna get going. Now, something else that is really important is that we're looking at the kit here, but you do need a couple of additional pieces to be able to make this kit really work. First, you need to have a console connection. So you basically need a USB cable that you can use for the FTDI connection to get that serial console. It's very important. We actually tried doing it with a monitor and that didn't work for some reason. So they say just use the console. We're gonna say use the console. That's just the way it is. Second, you're gonna need a little micro SD card. So we have a little SanDisk 16 gig card here, and that we're gonna use for our OS storage. Next, you're gonna need a power adapter because you're gonna wanna get power to this board. You're also gonna want a monitor, which we're using this Asus unit here because, well, it has an HDMI input. So that's the reason for that. And then we also have a Logitech Brio USB camera. Now this board can take MIPI cameras as well, but we're using the USB one because, well, that's what we're gonna use. All right, so let's get to it. First thing we have to do is we have to go get the image for our micro SD card off of the Xilinx website. And there's a getting started guide, which makes this super easy. And it's basically, a lot of this is just copy paste ready to go. But the first step does matter a little bit based on which OS you're in. We're gonna use Windows here, but you could use Linux or Mac OS as well. Now, the one step that I did cheat a little bit here is just that I figured you didn't really wanna go watch like 10 minutes of downloading and then also burning the image to this. The one thing I will tell you though, during that process that I learned that I didn't really necessarily like is that if you don't have an existing Xilinx developer account, you need to create an account because the image to go run on the custom Xilinx FPGA is behind a registration wall. This isn't bad, but at the same time, it is just another step that you don't see in some things. Like for example, if you're gonna do Raspberry Pi or something like that, you're not gonna have to go do that registration. So I do kind of wish that Xilinx would just take that image and then not put it behind like some kind of trade compliance and registration wall. But basically the exercise is that you download the image and then you burn the image using your favorite image burning tool onto a micro SD card slot. One thing that was not present in the instructions for Windows was actually the fact that this is a .gz file and you have to actually extract it. So we use 7-zip and we're able to extract it. That's not in the instructions, but it is actually a step on Windows that you're gonna have to do. So now let's get this all set up and show you what that looks like. Okay, so step one, we gotta get our micro SD card and we're gonna pop that in the little micro SD card slot. Next, we need our serial console cable. So I'm actually have my laptop, if you can't see, right here. And what we're gonna do is we're basically gonna go put this serial console cable into this little USB port over here. And that's our serial console connection. And now that we have the micro SD card as well as our console cable connected, we're gonna get to the other side and just kind of pointing out some of the big IO features here. We have basically a gigabit Ethernet port. We also have 4 USB 3 ports that also can do USB 2. There's a display port and an HDMI port. Now, I asked the Xilinx folks about this, and they said that it's a either or. It's not both at the same time. So that's what they told me on this. So we're going to use, I think, HDMI for this. And then there's also a DC input jack. All right, so let's go start getting things connected. And I made a nice little bundle. Well, not really a really great bundle, but a bundle. We put our Ethernet cable in. So we got Ethernet now. We are now going to connect our camera, which is important. Then we are going to connect our HDMI. And finally, we're going to do our power. But you want to make sure that this is all connected before you start this process. Okay, so now what we're going to do is we're just going to go and we're going to start to power this thing on. And you're going to see some little lights lit up. Now, I don't know if you can hear this, so I'm gonna make it a little bit easier, I guess, for you to hear while this is all starting. There's a little fan on this, and this fan is actually part of the development kit. It is not part of the overall SOM. So you'd normally buy this SOM as just like this little module that's in the middle of this carrier board, but for development purposes, you get this nice little cooling solution as well as the carrier board. Now, this fan, Xilinx told me, was very quiet. But here's the thing, I don't think it is quiet at all, actually. It's quite annoying. And the microphone is right here. And I'm gonna lift this up a little bit. Maybe you can hear that. If you can't hear it, I don't know how it's gonna turn out, but if you can't hear it, it's pretty darn annoying, just frankly, how loud it is. Now, what the Xilinx folks told me that you could do, because this thing is only a couple of watts, is that you can actually unplug the fan. Now, if you're in a really hot environment, you probably want to keep the fan on, but at the same time, if, let's say, you're recording a video and you don't want to hear this fan noise because it can drive everybody absolutely nuts, or at least me absolutely nuts, you're just going to unplug this during the setup process. And now it's silent. Again, I did ask the folks at Xilinx and they gave me that recommendation. Now, what you probably noticed was that on this screen, not a whole lot happened. And the reason for that is that the way that you really want to set this up is via the serial console cable. When I originally set this up just to try it out on I actually used a Tiny Pilot IKVM, and that really kind of didn't go that well at all because I was trying to use this kind of local interface to log in. You want to use the serial console interface. I wish that you could just hook up this to an HDMI monitor, put a keyboard in there and go without the serial console. Like why do you have to have the serial console? I don't really know the answer to that, but I do think that that's something that maybe Xilinx could do a little bit better on, is just make that a little bit easier. Let's face it, pretty much everybody has some kind of display these days that will accept HDMI input, and so that would make life a little bit easier for some folks. Now, what we're going to be using for this is Xilinx actually has a pretty awesome little starter guide and like getting started guide on how to go do this. And so the first thing you're going to want to do is set up your serial console interface. We're going to have the instructions on the screen for that. Then once the system boots up, what you're going to want to do is actually log into the system. You're going to have to set a first time password. It's, I think, Petalinux, and then it's going to be Petalinux again. But basically, after you change that password, you're going to use that to log in. The other thing that you will do is you want to go and elevate your privileges. So you're going to go elevate your privileges in the system. You need that because you want to go do things like, I don't know, program the FPGA, for example. And now that we're root, we can actually start installing packages. And so Xilinx, we can use the getting started guide, and they have the basic packages that you need to go to. You just copy paste the commands, and you're basically all set. Something else I will note just at this point is that once you have set that password to something that's different, you can actually just use SSH and log in directly to that, not using the console anyway. So frankly, that's probably what I would do. I just don't like cables, so I don't like having this extra console cable. I'm going to fast forward this a little bit because this is just a whole lot of stuff installing. Now that we have our package installed, the next thing we want to do is see, well, what apps are available or what apps are installed on the FPGA currently. And one of the first things you have to do is actually unload any of the FPGA apps that are already on there. So that's what we're going to do right now. Again, this is all copy paste. Next, we want to go and install the Smart Cam. Now, at this point, we're only a couple minutes into the actual setup process, and we actually have a functioning development platform. We already have a SSH and a network connection. We have USB connections. So there's already a lot going on here. This is way easier than designing your own product. Now, at this point, not only do we have the base development platform set up, but we also now have an application and an accelerator that's now on the FPGA. And this is where things start to bifurcate a little bit. So if you do have a MIPI camera, which is super, I guess, common in the industry, that, you know, you use the first command, which is the Smart Cam MIPI, and then you basically come up with resolution and then your target. Okay, so we just started this up. And wow, that's really terrible looking. All right, so we got this all set up. What I noticed was that the camera is actually pretty bright. The webcam does not like the studio lights, so that's actually you guys right there. You can see the Canon C70 right there that I'm looking at. But in theory, if I put this around myself, you can see that there's actually a bounding box around my face. So what this is actually doing is this is now doing facial recognition, and it's saying, hey, there's a person there. And what's kind of fun is that right about there, once I get my nose on there, I don't even need eyes, and it's actually recognizing me right now with that as well. Man, you guys are getting a lot of behind the scenes footage with this, huh? Now at this point, you can see that we can see the studio. So we have a functioning video working. We also have the Linux operating system. We have an entire board with all the inputs, outputs that we're using, and everything's now set up. We can even do facial detection, and you can see me and bound my face. So it's obviously recognizing the fact that there's a person there. So what this practically means is that we're now at the point where we're ready to start using this. Now, let's say that we wanted to create an application, for example, that would recognize my face and then allow me entry into my door. Well, what I could do now as part of my developer kit experience is to go use Python or something like that and start to go build my application that says, okay, that's Patrick, let him in here, or that's Patrick, it's the cookie jar, it's too late at night, do not let him in. I do like cookies a lot, so that would be pretty useful. But frankly, having this set up at this stage without having to go through a lot of effort and stuff, I think it's actually really awesome. Something I will note is that there are basically two getting started guides. There's the one on the website, which that's the one that we just followed and I've been showing you, but there's another one on GitHub, which actually has some extra bits that are really useful. For example, for using your vision accelerators, what you can actually do is you could use something like a file that maybe is like an MP4 or something like that file where you want to go and import that, I guess those images or that video stream, and use that to go do your recognition on and do your training on. You can totally go do that. And the guides for that are on the GitHub page. So the other thing that you can do is you can actually go and set up and use Jupyter and go start using that to go manage and start doing your development. So Xilinx has really thought about, what is the developer experience and making it so much better than the previous generation of FPGAs. Now, something cool that I'm showing off right here that you may or may not be able to see is that I'm taking a video using the camera of the screen, and my face is still in the shot. So it's actually bounding on each of these. It's actually bounding my face in the video on each of the different levels. So that's kind of just a fun little thing here. The other thing that we should note is that this is only the smart camera. So this is really just one of Xilinx's applications. Xilinx also has some other applications because they're now coming out with an app store concept. So while this is really the smart cam, there's also a couple other applications. For example, there's a AI box with ReID, which can take multiple camera streams and actually track things like pedestrians. So if you're like monitoring a crosswalk, for example, you could track pedestrians walking across that crosswalk or different crosswalks using this single board and multiple cameras. There's also a defect detection app, which allows you to go and find things that don't look right. The example that they're using is like a apple and a bad apple. And so the idea there is that if you're really doing something like an industrial application, manufacturing application, agriculture, something like that, you'd have the ability to use that app. But those are Xilinx apps. There's also apps from third parties that you can already get. And one that I really wish that I was able to try, but haven't been able to get the license to it yet, is there's actually an AI box for auto license number recognition, because I just want to go track, all the people that are coming in and out of my long driveway. That's like 5 meters. No. Yeah, it's about 5 meters long. Okay, that was getting entirely too distracting with my face like 5 times over here. That was way too distracting, and I don't really want to see my face that much anyway. So here's basically the deal. Xilinx now has this Kria platform, and the basic idea is that you can get started if you're a developer very, very fast with this. You can start using FPGAs, you can define your own custom logic, and you don't necessarily need to go through the entire process starting with like, here's a chip, go define all your memory interfaces and camera interfaces, all that kind of stuff. Xilinx already has that done for you. Beyond just the hardware design, there's also the software bit, and for getting this started, as you saw, frankly, that was super trivial compared to any other FPGA product that I've used before. And there's already a number of prepackaged applications basically in an app store format. Now, of course, this is nothing like the Apple iStore in terms of volume or anything like that, but the idea is that not only Xilinx, but also third parties will be able to have apps published on that app store, and then you can take advantage of them. Some of them you will, of course, have to pay for if they're from third parties or maybe from Xilinx, but that's just the way it is. The key, though, is that you can get set up with the hardware, you can get set up with the software and the basic tracking and all that kind of stuff without having to do anything. You can then use your time as a developer developer to start doing your own custom logic. Like for example, when I use that entry or video-based entry algorithm, that's a good example of where you could say, okay, well, now that I can see a face, I can figure out who it is. Now what I could potentially do is start allowing or denying access, and I'm going to go as a developer write that portion of the application. If you wanted to make a product on smart cities and do pedestrian tracking or something like that, you could totally do that as well, and you could just use something from the App Store. You don't have to go program it, train a model, and then implement it in FPGA logic yourself. It's already done for you. So going back to my table analogy, this is really much closer to, hey, here, let me just drop ship you or have a table delivered rather than going to Home Depot and starting with a pile of wood and not having the right tools. Now, let's talk about cost here for a second, because there's kind of like 3 levels of cost that you should probably talk about. So the first level is really what this little module is here. Now, this module is the Kria K260 module. And that module is designed to be a $250 or $350 module, depending on if you want the commercial or industrial grade module. The idea is that if you had an application where you want to have, say, a bunch of cameras and you want to go design your own enclosure with all the cameras and all the backlinks and all that kind of stuff, what you basically do would be to buy this module, you'd build all the carrier boards and stuff that you would have for your specific application, and then you just put this little module in there and you would install that as part of the end package. But of course, you now can just do that using pins, and you already have a lot of the stuff like the DDR memory interfaces already built in. You don't have to go do that part. But this AI Vision Starter Kit, which is the KV260 AI Vision Starter Kit that comes with the board, the carrier board, as well as the module, you can get for only $199 at a $100 discount. You also get this little cooler, which you don't get on the normal module. Now you may be wondering, why is it less expensive if you get more? And the reason for that is that this kit is designed really to start getting started with that development. It's not necessarily for volume deployments. You just go get the modules for your volume deployments, but Xilinx is making it less expensive so you can get started. I will say, however, that I probably would not spend $199 on this. I would probably order the bundles, because there are 2 bundles that you might want for the system. The first one is that you have a power supply and adapter bundle, which is like, I think, another $25 or so for the power supply. You could go get your own, but at the end of the day, it's probably easier just to go and get one and spend the $25 and just get it and not have to deal with, did I get the right one or wrong one? Now, for $59, there's a power adapter, network cable, you get the 16 gig memory card, the console cable, you get an HDMI cable, as well as a camera module. And frankly, if I were buying this and I were telling somebody like go buy it, I would just frankly get this kit. Now, sure, you may have an Ethernet cable, so you may be wasting a couple dollars here and there, but it's much better to have stuff that's tested with a development platform than have to go do that yourself. And the other thing is just, frankly, if this arrives at the same time as your development kit, you're not going to be sitting around with like a development kit sitting there and like, okay, where is this part that I ordered from? Who knows where? Is it going to be there on time? When am I just waiting for it? It's better just to get it all at once and be able to start going once it arrives. That's at least how I would do it, but you can totally do it differently. Based on the fact that the tally light is still burning red right now and we're not blinking at me and the camera hasn't shut off, that means that we have definitely set this up in well under an hour. In fact, as you saw, it basically only took a couple minutes to get set up. Personally, I think this is a super important platform for STH readers and also you on YouTube, because this is a different model for Xilinx. You basically have something that you can plug and play. It's already doing things like detecting faces and stuff like that, and you can just layer on your applications and your needs and your specialized development bits. On top of that, you don't have to go all the way down to like hardware design or placing logic or anything like that. Now, of course, if you do want to go and you want to go learn FPGAs and really get into that, you can use the Zinc UltraScale Plus SoC and actually go use some of Xilinx's higher end tools and go start learning FPGAs on a platform like this, which some people might think is actually a reason just to buy this, maybe without all the AI accelerator and all the app store and all that kind of stuff. But enabling that from very low level all the way up to a pretty easy experience, I think is really new for Xilinx, and it's kind of amazing. I mean, if you think about a company that sells billions of dollars of chips every year, and they were just selling lumber and fasteners and tools and bits like Home Depot rather than selling you the finished table product. I mean, oh my goodness. So it is nice to see that between the Kria line, but also the Alveo line, which are the PCIe cards really for data centers, Xilinx is starting to move in that direction. I actually asked the CEO of Xilinx, Victor Peng, about this transition. He said, yeah, we thought that we could basically just go make a PCIe card, call it Alveo, put it out there, and it'll be so much easier because people didn't have to go do just the hardware design. And then we basically realized that, Xilinx, they needed to go and do some of these higher level application bits so people would actually adopt it. And I think that this is a awesome case in the fact that Xilinx has figured out that that's a market need. They figured out that they need the fully assembled table, and they're actually providing it now. Now, if you're watching this video and you're scratching your head, you're like, hey, so should I get this instead of Raspberry Pi? I think that for general purpose stuff, I would get a Raspberry Pi over this every day. On the other hand, if you did want to go create something that is unique and actually have an idea for a product that you wanted to implement, this is actually kind of cool. NVIDIA has things like the Jetson line, but that's using a GPU. And so there are reasons for, especially for latency reasons, that having a FPGA with a very certain pipeline is very useful for an application like this. Lower latency means better performance, and that's always good. And that's something you get with an FPGA. You could go build your own custom ASIC, but at the end of the day, you're not going to go build a custom ASIC if you don't have a large volume. This is great for if you're, doing a couple hundred units or a couple thousand units. You don't have to go and figure out how to do a wafer start at TSMC, plus do all of the design and packaging, all that kind of stuff. You can just basically drop in one of these SOMs and be ready to go. Man, that was a lot. But hey guys, I hope you enjoyed this look at the Xilinx Kria AI acceleration platform. And if you did, why don't you give us a like, click subscribe, turn on those notifications so you can see whenever we come out with great new videos. As always, thanks for watching and have an awesome day. And hey, while you're at it, why don't you give this video a like because my nieces are cute.
That's crazy, Uncle Pat.
All right, so at this point, this is a look up my nose, I guess. That's not good. It's kind of awkward though, isn't it? What the heck are we looking at there? Oh.